Hello, I'm the presenter Chang-Gyu to introduce estimate the difference threshold for curvature gain of redirected walking. Since redirected walking was first proposed, many methodologies have been developed. In addition, many studies have been conducted to find a detection threshold related to this. These include translation, rotation, curvature, and bending gain, as well as find detection threshold for redirected jumping and non-forward motion. However, in some papers that applied curvature gain, there were reports that perception occurred when the gain was changed, despite using a gain smaller than detection threshold. And there was also a study to find the difference thresholds for translation and rotation. However, research to find the difference threshold of curvature gain has not yet been conducted. Therefore, in this paper, we try to identify the difference threshold of curvature gain. Before, before going into details, first let's define two terms. Curvature gain, covered in this paper, means virtual orientation change while the user works, and the difference threshold means human perceptible change in gain, respectively. In this paper, an experiment based on two alternative force-choice tasks was conducted to find the difference threshold of curvature gain. Experiments were conducted using the first and second curvature gains, shown in this table. Here, first and second gains mean the curvature gains presented first and second in one trial respectively. Experimental conditions included increasing change and decreasing change. Change for curvature gain of 1.5 and 3.5 and 5 different magnitude of change. As shown in the figure, participants stood on one side of 7 meter by 7 meter real space, wore HTC Vive Pro, and held a Vive controller in their dominant hand to conduct the experiment. The virtual environment used in the experiment was a typical city like this figure, which included buildings, trees, roads, etc. When the experiment begins, the participants stand on the starting point represented by a red circle. Then, when the trial starts, the participants walk toward the green sphere 6 meters ahead. During walking, participants experience first and second curvature gains in turn. After reaching the green sphere, answer which curvature was greater among the two, and then stand again on the starting point and repeat the next trial. 23 participants participated in the experiment, and 18 of them had experience with virtual reality. Of the participants, 11 were male and 12 were female, and their average age was 27.13 years. As a result of this experiment, the probability to judge correctly according to the change in curvature gain could be obtained as follows. The error bars in the figure indicate the standard deviation. The results of curve fitting are these bold lines. Using this bold line, I found the difference threshold for curvature gain of 1.5 and 3.5. In general, the difference threshold is shown in the probability to judge correctly of 0.75. That is, a value of 3.73 was derived from a curvature gain of 1.5 and a value of 3.06 was derived from a curvature gain of 3.5 respectively. And if we combine the two results to find one difference threshold, it becomes 3.06. If 3.73 is set as the difference threshold, the probability to judge correctly close to 0.8 appears at the change in coverage gain for 3.5. Therefore, it is appropriate to select a lower value for the threshold. Next, statistical analysis was performed to check whether the change in probability to judge correctly according to the variation in change in coverage gain represents a significant difference. As a result, it could be confirmed that they showed a statistically significant difference from each other. Through this study, the difference threshold for curvature gain was obtained as 3.06 degree per meter. In this study, we conducted a study on curvature gain that changes abruptly, and in the future, we plan to conduct an additional study on curvature gain that changes gradually. Thanks for listening.